2.4 sum and difference. Let's get back to that. Handy dandy cardstock right here, sum and difference formulas. That's what I'm going to be referencing whenever I say something. Here's our sum and difference formulas. So let's get right into number one. Now, in number one, we don't have a special right triangle with 12 as the denominator. We do, however, have a special right triangle with radians with 3 and 4 in the bottom of the equation. So what we have to do is figure out what those two numbers are. So we can rewrite sine of pi over 6 as sine of pi over 3 subtract pi over 4. Why can we do this? Because of the fact that if we actually did this in our calculator, we would get pi over 12. So now we can come here to our handy dandy formula. If we have a subtraction sign of two different equations, we have this formula right here. So the first number is our u, the second number is our v. That's very important that you're seeing that. So if I have sine of u, so if I'm just looking at that equation, sine of u, so sine of pi over 3, because that's our first, times cosine of our v here is pi over 4, and then we're going to subtract cosine of our u value, which is again pi over 3, and then sine of pi over 4. So one thing about doing this is making sure to write the equation correctly, because people can get very confused on just writing this part out. From there, we can replace sine of pi over 3. Remember, sine is our y value. It's also going to be our opposite. So in this case, that would be the square root of 3 over the square root of 2 times cosine of pi over 4 is going to be the square root of 2 over 2. That's rationalized, minus cosine of pi over 3 would be 1 over 2 times sine of pi over 4, which would be the same thing. Remember, sine and cosine of pi over 4 are the same. Now, if I multiply this across, I would get the square root of 6 over 4 minus, this becomes the square root of 2 over 4. And because they already have like denominators, we can have the square root of 6 minus the square root of 2. You cannot simplify that any further. So this would be my answer. So that's when I'm dealing with radian measure. Here, if I'm looking at this 75, if it ends in a 5, that's going to have a 45 with it. So I'm going to rewrite 75 as an addition of 2. So I can rewrite this as cosine of, let's say, 45, because I know it ends with a 5. So if I do 75 minus 45 plus 30, that is equal to 75. Now I come back here. Here's my cosine adding. Now for this one, it doesn't matter as much which one you have first and second, because adding it doesn't matter. But it does matter the once you plug it in here. So if I have cosine of my addition, it's cosine of my first value. That's my u value. So the cosine of 45 times cosine of my second value, which is my v value, 30, minus sine of my u value, which is 45, times sine of my v value, which is 30. And you simplify each one of those. So my cosine of 45 is square root 2 over 2 times my cosine of 30. Remember, cosine is going to be my x value of this this angle, square root 3 over 2 minus sine of my 45, which is square root 2 over square over 2, times sine of my 30, which is 1/2. Same thing if I multiply across, I have the square root of 6 over 4 minus the square root of 2 over 4. Oh my gosh, it's the same thing. And one thing you will notice is because of the fact that we are dealing with the same numbers and with this unit circle, you're seeing these patterns, these numbers show up each and every time. This is a common thing to have the same answer, but with a different trig function at the beginning and a different angle at the beginning, because it all depends on what's going on here. So for question number 3, it's a little bit different, saying give us the sine of 4 over 5. Find the value of u plus v when we know sine is 4 over 5 and cosine of v is negative 3 over 5. So if we're looking at this sine value, you know you're going to need the sine of u and cosine u. You need the cosine v and sine v. So we're going to set up two different right triangles for this. So if we know that sine is 4 over 5 and it's in the first quadrant right here, That's this opposite over my hypotenuse. I can use my right triangle, a squared plus b squared equals c squared. And right here, this is saying it's going to be in between pi over 2 and pi. So this is in the second quadrant. This is my adjacent over my hypotenuse. And I use my a squared, b squared, c squared. You would get that my missing link is going to be 4 for both of these. I'm sorry, 3 for both of these. So now again, we're looking for adding our two angles. So we're looking at this equation right here. So we have sine of u, which was given to us. Our sine of u was 4 over 5 times our cosine v. So that cosine v was given to us, that negative 3 over 5. And then this time, because we're adding, there's adding in between here. So it's very important to always look at what you're doing. So here's my u. So now I'm looking for my cosine u. So cosine u would be at 3 over 5 times my sine v. So here's my v. My sine is my opposite over my hypotenuse. So this would be 4 over 5. And this becomes negative 9 over 25 plus this becomes 12. And by negative 9, I meant negative 12. 12 over 25. In this case, my answer would be 0. So looking at example 4, we have write this as an algebraic expression. Well, we have our cosine. They're adding here. So again, cosine and adding. This would be a good spot to label what your u is. So my u here is going to be arc tan 1, and my v is going to be arc cosine x. So if you're looking at our cosine adding, it's cosine of our u. So cosine of our arc tan 1 times our cosine of our v. So cosine arc cosine x minus, so when you're adding, this is actually equation is minus. When the cosine's adding here, it's subtraction for your formula. Sine u, which is arc tan 1, times sine v, so which is sine of arc cosine x. So if I look at my arctan, so this is saying arctan of 1. So if I have 1, tangent, remember, it can be in the first or second. It's positive. It's going to be here. That's 1 over 1. So this angle right here is my theta. So in this special triangle, this is square root 2. So now this part right here is saying the cosine of this triangle. Okay, so we're going to first simplify that. So my cosine is my adjacent, which is 1 over square root 2. So this simplifies to be 1 over square root 2 times. Here, this one's a little bit easier because arc cosine and cosine, those can cancel out x. And we're subtracting. Here we're going to use the same triangle. Here's my arc tan 1 right here, but now I'm looking at sine of that. So my sine of this is my opposite, my 1 over square root 2. So that'd be 1 over square root 2. This one's not as easy, so I'm going to do my arc cosine. So when we do not have a actual number, cosine numbers in the first or second, we're going to assume that's in the first. So my cosine would be my adjacent is x, and my hypotenuse is 1. So if I want to figure out my third side, it would be the square root of 1 minus x squared. That's right there. So again, that's my arc cosine x. That's this picture. So now if I look at the sign of this problem, my sign is my opposite. Here's my opposite. So this is going to be multiplied by the square root of 1 minus x squared over 1. So now let's simplify this sucker. So when I multiply this across, this becomes x over square root 2 minus square root of 1 minus x squared over square root 2. Now I have my like terms there. And we have x minus the square root 1 minus x squared over square root 2. You can leave your answer just like that. You do not have to rationalize in this format because we do not know what x is. So we can leave our root just like with the square root 2 over it. So here's in the proof. This is like our u. This is like our v. Pause the video and try to write out that formula first. So this is what we have. So now remember, this is pi over 2 right here. Cosine is your x value. Sine is your y value. So cosine, this changes into 0 times cosine x plus 1 times sine x, and 0 times anything is 0, leaving me with just sine x. So this is how we would prove that equation. So for A here, I want you to first try to write out the formula before we simplify. So write out the whole formula with cosine subtraction. This is your U, this is your V. So pause and try to do that first. And here again, we're simplify where we can. So this is 3 pi over 2. This is right down here. So cosine is our x value. Well, my x value here is 0. So this would be cosine theta times 0 plus sine theta times, this would be our -1 because it's your y value, -1. So this becomes a 0. This becomes a negative sine theta. That would be my final answer. I want you to try to do this one right now. Write it in your tangent equation. So this is how we write it out. So we don't have anything for our tan theta as of yet, but we do know that tan of 3 pi, so again, 3 pi would be right in this location, right there. So our tangent is always going to be our y over our x. So in this case, the tangent of 3 pi is 0. Whenever I see a tan of 3 pi, I can replace that with 0. So that'd be 0 there. 1 minus tan of theta times 0. So this would reduce to just 1 because this would be 1 minus 0. This is also 0, so this just reduces to tan of theta. Wowzer, that one looks hard. So first thing I want to do, notice that we have a sign of addition and a sign of subtraction is equal to a number. So right now I want you to try to write out the whole equation that we have to try to simplify to figure out all the solutions on this interval. So this is what it should be look like when you write it out. One thing I noticed, this cosine x sine pi over 4, negative cosine x sine pi over 4. These two right here cancel. So this is gondo. These are also the exact same. So this one here and there's one here. So we can rewrite this as 2 sine x cosine pi over 4 is equal to -1. Now if I look at cosine of pi over 4, so I'm looking at my cosine pi over 4, that's going to be my y or my x value at pi over 4, which would be equal to square root 2 over 2. So we have 2 sine x. This right here is equal to the square root 2 over 2. Well, now I notice that these two right here, this 2 in front and this 2 right here, can cancel each other out. So the square root of sine x is equal to -1. I get that by itself. So now we have this. Now, this is something that we have done so many times before. So it's negative, so all sad, so it's going to be in these two quadrants. My sine is 1, my hypotenuse is square root 2, so this is going to be 45, 45. So if I'm looking at my reference angle here is 45, so I'm looking at these two angles. For here, this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 over 4. This angle right here is going to be 5 pi over 4. This is 6 pi over 4 right here. This angle right here is going to be 7 pi over 4. So this all right here led us to all of the algebra that we are smart and we know that we can do to end up getting right to that same spot that we have been doing. There you go. Bing, bada, boom. Have a grand and wonderful day.